What a week. It's great to be back here with you guys. I feel like it's been a long time. OpenAI just killed more than 1,000 startups with their latest announcement on Monday with GPT-4 Turbo, 128K context window, Assistants API, Turbo with Vision, DALL-E 3, JSON mode, and tons more. You already know this though. You've been deep diving into videos, content, code, and are likely rushing to keep up with what it means for your engineering work and your product work. Since OpenAI Dev Day, I've been spending every free minute exploring, researching, questioning, and condensing my learnings into pure oil to understand what this means for you and I as product builders. There's a ton we can talk about, there's a ton we can cover, but I don't have the time, we don't have the time. So let's focus in on the bigger meta game by looking at OpenAI's most interesting and most technical announcement, the Assistants API, backed by GPT-4 Turbo. In this video, we're going to break down GPT-4 Assistants API into a clean, reusable Python structure that we'll use on our Postgres data analytics tool we've been building over the series. By using a real use case, this will give us a better understanding of the value, the use cases, and how it compares to plain GPT-4 chat completion calls. We'll then touch on the macro institutional level of what all these changes mean. Then we'll dive into the smaller micro. None of this matters if we can't conceptualize it and condense it down into what we can do on a day-to-day basis. Thinking, planning, building, turning these incredible tools OpenAI is giving us into real concrete value for ourselves and for our users, customers, and clients. If this sounds interesting to you and you are excited to cultivate a calm, collected perspective and action plan, hit the like, hit the sub, and let's build a reusable GPT-4 Turbo Assistant we're going to call Turbo 4. As always, let's start by recapping our multi-agent Postgres data analytics tool. In natural language, we can ask our multi-agent tool any question about our Postgres database. For instance, let's reveal all negative job feedback. At a high level, our application is very simple. We take a natural language query against our database, we load in tables that are relevant, and then we use a series of LLMs backed by OpenAI to generate the SQL, run it, and report all the data to a file. We also have a special insights team you can see here, generating interesting additional queries that offer us business value in some shape or form. You can see here our team completed. We get reported the costs. Here we have a clean report of everything that happened in the run. We have the results in a clean JSON file, and then we have our innovation file, which has a report of all the interesting insights that our agent is pushing to us. And then we have a clean agent log, which records the conversations between our LLM agents. You can see here the admin's talking to the engineer, passing the original query, then the engineer to the analyst, and then the analyst is calling the function that it needs to run and report the results to our run SQL file. So how does this work? We accomplish this by using AutoGen guidance and a clean, reusable application structure. Let's go ahead and walk through it briefly. You can see here at the top, we have a Postgres database URL and an OpenAI API key. We then take in the prompt, we prefix the prompt, we build a session ID, we open up the scope of our Postgres agent instruments, which acts as a store for our agents. You can think of this like Redux or Pina or a front-end store, but it's for our agents. It contains functions and state that they can use and manipulate. We then have a gate team that determines if this is a valid natural language query against a Postgres database. We then use embeddings and a simple word matching technique to get all table definitions that our query will need to run. After we build the prompt, we have our data engineering team. We run a sequential conversation, which runs top to bottom. Agent A passes to B, B to C, C to D. Then we look at the result of that and we do some logging. And then our final team, the data insights team, takes another prompt based on the original prompt. It takes a different set of tables that are also related. Then it builds its own unique data insights team, runs a round robin conversation so that we can arbitrarily increase this to 2, 3, 4, 5. And it'll generate batches of insights for us. That's our multi-agent team. We've done a ton here. Check out the previous videos in the series if you want to get caught up and understand everything that's going on here. All the code for previous videos in the series will be linked in the description. This series is leading up to a product called talk to your database. If you're interested in being one of the first ones to try it, link's going to be in the description. I'm really excited to bring all the work we've done to a fully usable product that we can use to get real value from and interact with our Postgres databases in a new, seamless way. Feel free to sign up if you're interested. So let's dig into the Assistants API so we can really understand the value. Whenever I'm looking at a new API, I like to break it down, figure out how the entities relate to each other. So let's look at this. So we have, at the top level, we have assistants, threads, right? So you'll have many assistants at the top, then you'll have a list of threads, and then threads have messages, and threads also have runs. And then we have assistants also have files, something called steps, tools. And let me put the tools up here as well, because your threads can also have individual tools, which is really cool. I'm really excited to show you how you can utilize thread level tools. I think it really changes the game in terms of getting full control over when functions run. That's what the API looks like. I want to build out a brand new workflow starting from scratch. Whenever something new comes out, don't try to automatically integrate it into your pre-existing code. That's going to be a hassle. You're going to make mistakes. Things are going to not go the way you want them to right away. So I always recommend start from a blank slate, work your way back up. And then once you understand the system that you're building and you have a decent wrapper, you have a decent kind of structure for it, then integrate. So that's what we're going to do. We're going to take 2 steps here. We're going to build out our Assistants API wrapper. We're going to call Turbo 4, run it on a basic example. And after we kind of understand and conceptualize all of these different API entities, we're then going to integrate it into our Postgres data analytics tool. We'll replace our data engineering team, this workflow here where we're generating the SQL and then we're running it, and then we're saving and reporting all the files and reporting costs and whatnot. We'll replace this code with our brand new Assistants API. So let me cook up a fresh example in a brand new main file. Let's code that right now. Okay, so let's break this down. We now have a brand new Assistants API wrapper called Turbo 4. If we look at our application structure, we can see we have a new top-level Python main file. We updated our Poetry start script to also include a turbo. So now we can run this Poetry run turbo and have our new script kick off. If we hop over to Turbo main, we can see we have a couple things here. So let me just uncollapse all the code here. Let's just start from the main file. We're building our new Turbo 4 assistant. We're building a turbo tool, which takes the name of the function, the config, and the actual function. And then we have our assistant. So we're saying get or create assistant. We don't want to keep creating assistants every time we run. So we're saying get or create. We are then saying make thread. So just like we looked at the top here, we have assistants and assistants have threads. We're giving our assistant a list of tools, which is our list of turbo tools here. And then we're adding a message, create 10 random facts about LLM technology. After we add that message, we're then actually firing off our thread. So everything up to this point will start running and the LLM will then respond and add its response to a list of messages. Now we're kicking off a run, and this will of course include steps as well. And we have messages in there. And then after we get that result back, we're saying use the store fact function to store one fact. I'm being really explicit here saying, I want you to use this function and I want you to do this thing. Once again, we run the thread. So keep in mind, this is all the exact same thread, right? So the great thing about the thread API is that OpenAI is giving us the ability to chain together messages. And then when we run a new thread, it's referencing the information in the previous messages in the thread that it needs to run the new set of messages, right? So if it doesn't need to reference anything we've talked about in the past, it won't. It's then taking this message, looking at the previous messages, and then running our store fact function, in which we trigger by passing in this toolbox parameter where we say, run all these functions on this thread, right? So let's go ahead and look at what this looks like with an actual run. So I'm just going to hit enter here. So what you'll see here is a bunch of log messages that I place at the top of each function, just so we know exactly what's going on. So you can see run thread, you can see equip tools, you can see make thread. And I just like to do that so it's easier to debug when I'm building out new wrappers, new modules, etc. You can see here, add message, generate 10, run thread. You saw it froze there for a little bit. And let's scroll back up. Run threads with the store fact. Run thread has a log message here. It's storing one of those facts. But then you can see at the bottom here, we have a print assistant messages. Let's go ahead and copy this out. Let's change the language mode to format. And if we start at the bottom here, we have from the user to the assistant. So from us to our LLM, and generate 10 random facts. Sure, here are 10 random facts. Use the store fact function to store, and then it's stating the fact that it's going to store here. And if we look at our store fact function, we just have this log here. So we should see this store fact log get printed somewhere here, and there we go. So you can see that came out right here. So this function did actually get called. This is great, right? It looks really clean, really simple. Let's look into what is actually going on here under the hood, right? So let's go to our Turbo 4 assistant and let's break this down. So you can see here we have a class and the init function. We set up several variables. The kind of key ones here are map function tools. So this maps the function name to our turbo tools. And again, turbo tools is just this name, config, callable function. And we have the new GPT-4 Turbo model, of course, and preview mode. We have some polling, some local messages, etc. But the most important things are here. We have our tools, our assistant ID, and our current thread ID. We have a property. That is our chat messages, and chat messages is just a sort of all the thread messages that we've saved that we load back from the thread API, right? So you can see that all here. We have our tool config. So this just loops through all of our turbo tools that we passed in, and it gives us back a config. We then have a set instructions function, which first makes sure that we have an assistant ID, and then basically it's going to update our assistant. So you can see here, we're diving into that assistant's API, take our assistant ID, and it's going to, set the instructions. But, even before that, we have get or create assistant. So this is really important, right? We have a call to all of our assistants. I'm matching by name because I don't want to keep duplicating our assistant, right? And if the model is different, we go and update the model. That's kind of a minor detail, but if this is the first time we're doing this, we're going to create a new assistant. Otherwise, we're going to match and store our assistant ID that we can reference throughout the creation of our threads and messages and etc. Right? So that's how we get a new assistant. And then to get this cool chaining functionality, this is called function chaining. What I'm doing here is every function returns self. You can, if you wanted to, do this, right? You can, if you want, just do this and, call your make thread, call your equip tools, call your add message, right? You can do this if you want. It's just a little wordier and this is a bit simpler. And I just kind of like the way that this flows, right? You can read it top to bottom and see exactly what's going on. Either way works. We have equip tools. Again, just doing a validation check. We always need our assistant ID. So this forces us to make sure that we call this function first before we can call any, additional chaining functions. But then we're just filling up our map in a really simple way. We have tool.name, which is the function name, right? So this is going to bind store fact to the turbo tool, right? So we're going to end up with just a clean dictionary of this. And then we have this if equip on assistant. So this is a really important thing to really consider. In the assistant's API, we have this tools array here in which you can set tools on the assistant. The problem with putting the tools on the top level is that if the assistant thinks it should run that tool for whatever reason, it will run it. I actually don't like this functionality as the default. I want to run tools, aka functions, specifically on certain threads. We're doing that here on this run thread call, which we'll get to. I'm saying toolbox store fact. So use this function on this thread run specifically. I don't want it to run arbitrarily whenever the agent thinks it's the best time to. I want it to run on this call specifically. This just protects the flow of the application from running a function when it's not supposed to run. As GPT improves, and I think it's gotten really good here, things like this will not be necessary. I just like it because it's a lot more explicit. So anyway, that's our equip tools function. So this gives our agents the ability to run specific functions based on the turbo tools that we pass in. And then the make thread, again, checks the assistant ID, and then it calls the OpenAI client beta threads create call, right? And again, all you need from that is the thread ID that you can reference in future calls. We reset the thread messages here, and then an add message, we're of course referencing that thread that we just created, right? Whatever we pass in here gets stored as the message, setting up a couple other state variables, and we're also refreshing the threads if it's passing true here, just a couple nice switches as convenient methods. Load threads is going to load all the existing thread messages. I should probably call this load thread messages. It's a little bit clearer because we're loading the messages from the thread. After that, we have this list step function, and this is going to combine our run ID with our thread ID, and it tells us where and what exactly our assistant is doing during API calls. And then we get to the core of Turbo 4 of really the Assistants API. It's this run thread function call. So this is a little dense. Let's try to walk through it here quickly. We do our validation checks of if no toolbox items were passed in, aka function calls. We set it to none. If they were passed in, we go ahead and get the configuration for the tool and set this up to be basically a list of configuration objects that we can call. The configuration object, of course, as you know, looks like this, right? So we have that. I refresh our thread messages. This is just for personal logging sake. And then we're creating our run. So this is, in our hierarchy here, we're now creating our runs, and our runs are going to contain IDs, right? And then we do this polling mechanism. This is the trickiest part of the Assistants API. This polling mechanism, we keep polling the API to see if this thread run has completed, or if it needs to run a function call, or if something else has occurred, right? Maybe an error has occurred. But if we look at this, we're constantly retrieving this run using the thread ID and the run ID. We're then checking if this requires action. Right now, requires action means it needs to run a function call. So then we loop through, we get all the tool calls that need to happen. This is where we're looking at our function map with the tool arguments passed back from OpenAI, and we're just running our function. So you can see here we have that dot function call. This is us running our function with the arguments OpenAI is giving us with the tool name it's also giving us. After that, we report basically saying, here's the output of the function call. We pass in the tool call ID back into a tool output. We're then submitting the tool call outputs back to the run, and then once everything completes and it's finalized, it'll give us back a completed status in which we just, once again, I just want to keep refreshing the thread messages so that we have them on our class in memory, right? So this is just a list call on the thread ID after the run has been completed, right? If it isn't completed, right, and it's still loading, we do this polling call where essentially it's going to keep running until the status is either, requires action or completed. Definitely want to improve this a little bit by adding an else statement, because this will just spin on if something has gone wrong, right? But that's what the polling variable is, and that is the Turbo 4. Let's go ahead and collapse everything so we can see that cleanly. Couple function calls. A lot of work is happening in the run threads. Basically, you're managing IDs here. You're making sure that your thread messages are, loaded when you need them. Definitely heavier on the code side, but this is what the Assistants API looks like. I really like how Turbo 4 is set up, because after we've kind of hidden the complexity of the Assistants API away in Turbo 4, we can then do really clean things like this, right? It's really obvious what's happening here. Get or create the agent, make a new thread, equip these tools, run this message, run the thread. Once it's complete, run a new message, use this tool, right? It's kind of like really intuitive, and this is going to be really simple to work with. So what I want to do now is take this example and replace our data analytics team, our team that's generating SQL and then running it and writing the result to a file. Let's go ahead and replace that team with the Turbo 4 agent. Okay, we now have Turbo 4 essentially completely replacing our data analytics team. Let's see how we've done that. If you've seen the previous videos in the series, you know exactly how this code flow works. We have the prompt at the top, a prefix here, fulfill this database query, and then here's where our Turbo 4 assistant comes in, right? So we're building our assistant. We're generating our session ID just like we were before. Instead, we're just going to use the assistant name. And actually here we could just use the raw prompt. I think we're using the raw prompt on the original version. Yeah, so let's go ahead and just do that, right? So let's do this, and maybe we prefix assistant name here just so we know it's Turbo 4 doing it. And then we open up, just like before, our agent instruments, which is our store and our functions and whatnot for our agents. We then have our database embedder, and what we've done is just kind of compress all that functionality into this function. Get similar table defs for prompt. So, all that previous functionality we had is just going to be in this function. So this is, our embeddings match. This is our similar word functionality, and this is our foreign key table lookup. So that's all happening here. And then we're adding the table definitions, adding it as a capitalized reference onto our prompt. We're then setting up our tools, and this is really cool. So, we have our Turbo tool. It's going to hit the run SQL functionality. We have a kind of slimmed down version of our run SQL tool configuration that looks like this. We're then using our agent instruments, which has our run SQL functionality, right? So really huge advantage of putting together smaller building blocks, right? We separated out our agent instruments into, an isolated class, which has, specific functionality, but it isn't really tied to any system, right? We're able to just like plug and play between the Assistants API and AutoGen function, and even just plain LLM calls, right? So this is really nice that we separated it out like this. We can jump in here and it's just a standalone function, right? Which is really like efficient and reusable, right? And as you know, we have our database getting generated up here. It's also part of the instruments output. So we get our instruments and our database. We put together our tools, and then just like as before, we have our assistant chainable functions running top to bottom here, right? So it's super clear. We have these extra functions here that were created. We can just comment these out. From top to bottom, we're setting our instructions. You're an elite SQL developer. You generate the most concise and performant SQL queries. We're equipping the tools, right? We're equipping this to run SQL. We're adding a message, which is the prompt we generated up here, right? So it has all the table definitions it needs. We're running that chunk. So it's, first going to generate the SQL, just like in our data engineering team. And then after it generates that, we're then saying, use the run SQL function to run the SQL you've just generated. And again, we're explicitly passing in the tool we want it to run. This is like really important. We're specifically passing in this tool here, which then gets loaded and passed in during the thread run, right? So you can see here during this thread run, we're saying, here's the thread ID, here's the assistant ID, use these tools. And we're explicitly calling out the tool right here. We then have a couple additional functions to kind of replace the work that our orchestrator was doing previously. So we have, run validation. So this just proves that our agents actually did what we asked them to do. We set this up in, I think it was video 2 or 3 of this series. We then spy on our assistant, which is basically just, going to report the conversations it's having. It's going to save that to this file, again, specified by our agent instruments. We're then going to get the costs and the tokens and report that as well to a make agent cost file. So let's go ahead and run this, right? Get all Gmail users. So we're definitely missing our gate team here, and we're missing our insights team, but I just want to focus in on the Turbo 4 assistant and just, isolate on this and see if we can indeed replace our previously AutoGen multi-agent team with just a single assistant running 2 different prompts with some additional functionality, run validation, spy on agent, get agent cost. So let's see how this runs. Okay, so you can see we're kicking off here. We have the prompt, we have the table definitions, we made a thread, we added the message, set instructions. You can kind of see it all top to bottom. Get or create agent, we're passing in Turbo 4, GPT-4 parameters there, but let's go ahead and see how it's done. Okay, so it's done already. You can see here, again, we ran that thread up there. We added a message, use SQL. You can see it did that exactly. It's running the run thread with that run SQL call. And then it's specifically saying, calling run SQL with these parameters, right? So it's perfect. And then we ran the validation as well. We can see agent results. We have the agent chats, and we can see that, again, that same structure from and to. And I think this is bottom to top here. So no, top to bottom. So you can see here, fulfill this database query from assistant to user. So from the agent to us, it's saying Gmail users from provided table definitions. We just look at all email addresses in the users table with the end suffix of @gmail.com, right? So it's providing this SQL for us, which is awesome. We can see that in the SQL query file. Exactly what you would expect. And then it is running that, and the result we return from that function, run SQL, right? We just say something like, yeah, good, successfully delivered. And then it reports to us, I'm going to run this function, and then it was successfully delivered and executed. So that's great. That all ran fantastic. And of course, we can see the results here. We have 3 Gmail users. We've looked at this before. If we go to our tables, look at users, sort the email, we can see we have 3 Gmail users, Alice, Bob, Charlie, and you can see, of course, Alice, Bob, Charlie right here, right? So we have all 3 of those. Fantastic. We're also reporting the cost. So you can see that run cost is about 2 cents. So another important thing we just haven't had time to touch on here is the Files API. So, the Files API is part of what makes the assistant so valuable, right? We can upload specific files, attach them to our assistant with the create assistant file, and then throughout all of our run thread calls, it will automatically look at that file when it needs to. So that's something we didn't get to here. That can easily be added to Turbo 4 as another call where we create and read files and make sure that we haven't already created that file. So that's an improvement we'll likely make here in a future video. This is a fully running Assistants API with a really clean, reusable structure that we can use to solve any problem, not just our specific SQL generating problem, right? You can see us using this to replace our gate agent. We could use it to replace our insights agent. And honestly, really interestingly, we could replace our entire Postgres data analytics teams with a single assistant, essentially, right? I think that gets into a deeper discussion of, is that the right way to go? What are the pros and cons of multi-agent teams, using something like AutoGen versus, just use a big assistant? When should you use tools like this? This looks really cool. It looks really incredible. We have it here. You can get the code, link in the description, right? You always have to consider the pros and cons to things like this, right? We have this clean structure. If we go back to our previous version, our AutoGen plus guidance version, we have a lot of like really clean structures here already set up. And, we have the team orchestrator and whatnot, building out specific teams, right? We have data engineering team, data viz team, scrum master team. This flow is really great. It works. The assistance approach works. We can push this even further. Let me just real quick code this up. We can go even smaller, right? We could do something like this, right? So this is an even simpler solution where we literally just have 2 prompts running against the OpenAI API, right? This is the chat completion API. Super simple, super concise, kind of doing the exact same thing, but it does it in 2 calls instead of 1. Generate the SQL, take that SQL and run it against run SQL function. And then we have the validate function right at the bottom here, right? Just like we did with the run validation call, right? So we have these 3 replacing all of this and all of the API calls that's happening in this assistant. When you're building these tools out, I really think it's important. I've talked about this on the channel before. I'm going to be a broken record about it. You want to be building blocks. Don't think that any single implementation is the way to go, right? This is a kind of really clean, structured format, really clean class where we have a lot of complexity isolated away. Do you need it? Maybe. There is definitely a time and a place to use a larger built out class like this. And there's of course a time and a place to just do everything in 2 prompts, run a validation function on it and just call it a day. There's also an argument for reusing our conversational flow that we built out with AutoGen and guidance. We have our orchestrator that can run many different conversation flows. My point is, don't get too attached to any one implementation. You want to have different sized building blocks to tackle different sized problems. This is part of the reason that OpenAI is building their APIs like they are, right? There's different use cases for all of this, and they're trying to figure out, what do we want as developers? What are we most interested in? What have we been most interested in? They're solving for a couple things here. So now let's get into the macro and micro conversation, right? Because that's where this is all heading. So it's pretty clear that these new capabilities from OpenAI are really incredible for engineers and builders that really embrace new powerful technology. What is happening here? What is OpenAI doing? OpenAI is becoming the most important company in the 2020s and beyond. It probably already is the most important company in the 2020s. A great sign of that is this announcement, right? OpenAI Dev Day, this blog post. Whenever a company's announcements causes industries to shift, you know that their technology is game changing. You know that what they're doing is very important, and this is where your eyes should be. This is where your time should be. OpenAI is becoming a platform for generative AI. It's best to think of them like the new Apple, but for LLMs. How do we know this is happening? How do we know they're making this transformation, right? We saw this with plugins. We see it with ChatGPT+. We see it with the paid API layer. We see GPTs, right? With their GPTs coming, right? We see the GPT store preview. We're likely going to see some, 15 to 30% commission on paid GPTs, right? It's pretty clear that on a macro level, for the App Store, for LLMs, GPTs, assistants, agents, they want to be a core provider, except it's looking like they'll own even more of the share than Apple does with the App Store, because the distance between them and Google or Anthropic or Facebook is about the same distance as GPT-4 is to any open source model, which is absolutely massive. In combination with these latest improvements, the 128K context window, lower prices, GPT-4 Vision, DALL-E 3, there's so many applications that can be built on OpenAI right now. It is incredible. I don't have enough time in the day to build all the things that I want to with this technology. I'm sure you have that feeling. I'm sure you can relate to that. There's just not enough time to crank everything out that you can imagine with this stuff. It's so incredible. That's such a great feeling. It also means that we need to focus on what matters, right? So let's go to the micro level, right? So that's a macro. OpenAI is trying to own the LLM stack. right? They're going to build platforms on it. They're going to offer services for us developers to build on top of it. And they're going to take a massive slice out of it, right? As they should. This is incredible technology. They've earned it and probably more. So let's transition to the micro level. So I think on the micro level, the day-to-day operations for us as operators, as engineers, as product builders comes down to like prioritizing, right? It's all about where should I be focused? You know, they just came out with a bunch of new tech. How should I think about this? Where should I be focused? Again, I'm a broken record. I am focused on code reuse, on building block reuse, on reusability, on composability. Real example, take the LLM.py file. 117 lines of code now. I have used this one file in so many applications I've built. It is incredible. And this is just a simple wrapper around chat completion, right? And I need to update this to the latest version. This is actually the old version. This has provided me with so much value, this simple one building block, right? This is the very base foundational level of interacting with LLM technologies. Simple prompt, pass in the model, and you're just like going, right? So much value unlocked. You can build on top of this. As we're doing in this series, you can build larger building blocks, right? We have orchestrators, we have agents, we now have Turbo 4 that we can use, right? We can reuse Turbo 4 for any problem, any system that we want to, right? Building blocks, building blocks, building blocks. The game is changing so rapidly. And, you know, I said this in the previous video. It's kind of funny that I did because that very same day, this announcement came through on November 6th, I think it was, right? Yeah, November 6th on Monday. When our previous video dropped, I literally said, these are patterns. The ground beneath us is changing rapidly, week by week. Don't take any code base, including AutoGen, including, you know, whatever else you're using. Don't take it as fact or something better than something else. Nothing is complete. Things are shifting and changing a crap ton. And the timing could not have been more perfect. That video launched on the morning of November 6th, and then this happened. Really just nails in the point. Be flexible. Focus on small building blocks. On the micro, that is the number one thing I can say. Don't overcommit to any one structure, to any one library, to any one capability that you have that you're building on top of this. The ground is shifting beneath us. You need to be able to shift and move with the ground. Ride the earthquake that OpenAI is giving us, right? It's a beautiful thing, but you don't want to get caught in the cracks. Keep aiming to understand the technology, keep playing with it, keep building products on top of this. There's a lot more here that we haven't covered that we're going to cover in future videos. Uploading files for our assistants to read, the image API. I mean, there's so much value here that's just waiting to be unlocked. I think the right way to unlock it is small steps, building blocks, composability, aim for reuse, don't overcommit to any one structure. I think that's the right way to think about this on the micro level. The lower level functionality is getting abstracted away for us. And I think you can expect to see this trend continue. We need to be able to apply our judgment against the options available to us to build the best product in the lowest amount of time to generate the most value for our users, our customers, our clients, and of course ourselves. I think that's another really golden nugget here. I'm looking at these tools as not only a way to build better products, but also as a way to accelerate my ability to create new products, right? This is a gold mine of a personal engineering workflow improvement. The number of improvements you can make to your own personal dev workflow with this technology is incredible. We're just scratching the surface of what's possible. So we have 3 videos left in the series. This is video 7. We're going to 10 videos, and it's all centered around our Postgres data analytics agent. It was really important to take a smaller break from that today to talk about some of this technology, to talk about the macro and the micro. I hope you enjoyed that. All the code's in the description. Just like you, I need some time to digest all the API changes, building out and tweaking some of our functionality, some of our building blocks that we've worked on so far throughout this series. I need to figure out exactly the best way to utilize this for our Postgres data analytics tool. Just like I mentioned, talk to your database is what this is all leading up to. This is how we're going to end the series. We're going to end it with a real live product. I'm going to show you guys that we're not just talking on this channel. We're not just sharing what we're learning. We're not just, having really in-depth micro conversations. We're also building it. We're going all the way. So in the next video, I'm going to have some more solidified decisions on how we're going to utilize the new GPT-4 technology for the Postgres data analytics agent. And finally, we're going to get a version of the Postgres data analytics agent live on an API so that we can start working on the front end for talk to your database so that we can seamlessly interact with our databases faster while saving a ton of time. Thanks for watching. Drop the like, drop the sub, and I'll see you in the next one.